স্যার আমরা কি রেডি ওয়েটিং আর রানিং এর মধ্যে ট্রাভার্স করছি না রেডি আর রানিং শুধু?
না, বেসিক্যালি ট্রাভার্সিংটা হচ্ছে রেডি টু রানিং,
হ্যাঁ,
কিন্তু রিজন বিহাইন্ড ইট ইজ আইদার এ রানিং প্রসেস উইল গো ফ্রম running state to waiting state, or a running state to terminate state, or running state to ready state. মানে somehow your CPU needs to be free, then only a process from ready state will be coming to the running state, and that is context switching.
আচ্ছা,
Clear?
ঠিক আছে।
That is context switching. Now the advantage of context switching is, if you allow context switching, then your degree of multiprogramming will be increased. Okay, or in other way we can say, to achieve degree of multiprogramming, we are going for context switching. To achieve degree of multiprogramming, we are going context switching criteria. ঠিক আছে? Now tell me, so during context switching, copying the state information of one ready state process or saving the previously running process, it is a time consuming affairs, right? And during the context switching, no useful task or no execution takes place by the CPU. So during context switching, as the state informations are copied from one place to another place, so there is no execution or instruction execution take in place by the CPU. So in one way, if you go for context switching, your degree of multiprogramming will be increased, but in the other way, if you go repeated context switching, then your CPU utilization may be degraded. So repeated context switching is not desirable, because during context switching, no useful execution is being done by the CPU. So repeated context switching is not preferred. If you go for repeated context switching, then CPU will be more busy with copy in and copy out of the process rather than actual execution of the instruction. Is the idea clear?
Yes, sir. স্যার লাস্ট লাইনটা বুঝলাম না।
বুঝলে না? এক মিনিট, অন্য কালার আমাকে একটু নিতে দাও। During context, see my diagram, I mean the slide. During context switching, the process which was running, its state information will be saved in the PCB, and a process which was in the ready queue, its state information will be copied in the CPU registers and all. Okay, so during context switching, this activity is being done by the computer system. So CPU is unable to execute any instruction. During context switching, CPU cannot execute any instruction, because during that phase, the state informations of the processes is copied from PCB to CPU and registers, and from CPU and registers to PCB. That's why actual instruction execution is halted. Very simple example. Come to the practical life. Have you ever seen, suppose you have 4 theory classes in the first half, first period, second period, third period, fourth period. have you ever seen that the first period takes place in the main building, main academic building? Second period takes place in the departmental lecture hall. Third period takes place in the new academic building. And the fourth class takes place again in the main academic building. Have you ever seen in this type of class routine?
No, sir.
Yes, sir.
देखा सप्तजी तुम्ही দেখেছো?
I said no, sir.
No.
I have not
Why
seen.
no? কেন এটা করে না?
So because student will take much of the time in traveling from one destination to other.
Rather than
studying
the class.
Uh,
Even if it takes 2 minutes to travel from main academic building to departmental lecture hall, you people will take at least 10 minutes to travel. You people will be telling that previous wala teacher ne choda nahi, or you will. So actually the thing is, which is actually takes 2 minutes time, you people will be taking 10 minutes time, and you will be wasting the time of the actual class. So my actual 1 hour class becomes 45 minutes class. So that's why all the theory classes which are in consecutive in a routine are normally put in the same lecture hall or lecture gallery, such that the traversal time will be minimized or make it to 0. So if you go for repeated change of classroom from first class main academic building, second class departmental hall, third class new academic building, fourth class again in the main academic building. So in every time you traverse from one classroom to another classroom, you people will be taking at least 10 minutes time. So student will be more busy in traveling in the corridor and from one classroom to another classroom rather than execution of the actual class. The same scenario arises if you go for repeated context switching. Then CPU will be more busy with swap in, the term is swap in and swap out of the process to the main memory and CPU rather than execution of the instruction. That degrades the performance of your system. বলো এবার বুঝতে পারলে কিনা?
Yes, sir.
কই ডাউট আছে?
না স্যার।
So in one way, through context switching, you are achieving degree of multi-programming. On the other way, if you go for repeated context switching, that will degrade the performance of your system. So we will be going more detail about this thing when we will be discussing process scheduling and all. Yesterday, in my last theory class as well as yesterday's third class, we discussed the fork operation. বলো কি হয়?
Sir, for একটা process কে fork করলে we get sub processes, sir.
It will create a child process.
Right.
So suppose there is a parent process which was executed. It executes the fork system call. The moment it executes the fork system call, it will create a child process. It will create a child process. On the other hand, the parent process will go to wait and will allow the child process for execution. Once the child process executed and it completes its execution, it will exit. Once the child process execution is completed, again the control will go to parent process. So the thing is, you have a main process, that is your parent process. In this process, you create a new process for with some code and all. So once you call the fork system call, it will create a new process and will be executed. This is a child process that will be executed. Once its execution is complete, the control will again go to the parent process for further execution. So that's why parent and child are concurrent in nature. Concurrent in nature means in our language or in a language of computer science, one process is in the running state, the other process may be in the waiting state or ready state. That we say as a concurrent process. So during the execution of a parent process, it may create any number of child process. It may create any number of child process. The child process again can create child process. This in turn again can create child process. This in turn again it can create child process. This in turn it can create number of child process. So it is something like a tree of processes. Okay, so you have a root process or the main process, the main parent process that creates number of child process. From there, it creates again two child process. From here, it creates one child process. Here, one child process. So the idea is one process can create any number of child process, and that child process in return can again create any number of child process. So both the child process and the parent process are concurrent in nature. Process executes the last statement and asks operating system to delete it. Parent executes the fork. As the return, it creates a child process. Child process start executing. While child process is in the execution, in the running state, the parent process goes to the ready state, and it will be waiting there to get the CPU cycle. So the child process is in the running state. Once the child process completes its execution, it will execute this statement, exit this. This will delete the memory space and the state information of the child process. It will delete the child process from the system, and the control will go to the parent process for resuming it. Process execute last statement and asks the operating system to delete it. Output data from child to parent. So output of the child process will goes to the parent process. And the process resource are deallocated. So whatever the resource that has been allocated for the child process will be deallocated. Maybe the memory unit, the registers, the input output file, all will be deallocated. And the task of child will be no more existence. It will transfer its output to the parent process. Parent process creates a child process, which in turn creates any number of child process and forming a tree. What about the resource sharing? Parent and child can share all the resource. That means whatever the data value, data structure, file informations, memory information, whatever the parent has, child can use it. Or a part of it can be used by the child. Or there can be no resource sharing. So you can implement for all the three cases. So if you have a parent process, this is my parent process. It can create a child process. Your code can allow both the process, the parent process and the child process will use all the resource. That means they have a common resource and they can share the resource. Or you can make a subset of the resource from parent will be used by the child. Or parent and child share no resource. Execution. What about the execution? Parent and children executes concurrently. Concurrently means, again, in our language, one process may be in the running state, the other process may be in the waiting state or in the ready state. Or if you have multiple CPU, then multiple processes can be in the running state. Parent can wait until the child terminates. So both the way you can implement, depending on the code you are writing. So parent will wait until the children is terminated. Okay.
Sir, is this something like recursion?
Something like recursion, yes. Yes. Right. Something like recursion. But in recursion, it will always call its, the same function. The function call itself. But here, a parent process is creating a child process. Now, depending on your code, both the parent process and the child process may have a common resource. You can keep separate resource for them.
Okay, sir.
There is another term called cooperating process. What do you mean by cooperating? Can anybody say? Forget about computer science.
Work together in tandem.
Huh?
The working together.
তোমার কথাটা খুব আস্তে শোনা যাচ্ছে প্রযত। প্রযত তোমার কথাটা একটু আস্তে শোনা যাচ্ছে, তুমি জোরে বলো না ভাই।
Sir, working in tandem, sir, working together.
Working together. Or anything else?
Communicating with each other.
Communicating with each other. Okay. Or kuch?
Sharing the
Working with mutual
Sharing the
understanding.
resource. Good. Any example of it in your daily life, in the hostel life?
Sir, roommates.
Roommates, yeah, very good example, roommates. So there are number of common resource in the hostel or in a particular room which you need to share with your roommate. There may be number of common resource. There may be number of common resource in a hostel room that you need to share together. Okay. Now, the sharing of resource, you should have some kind of common understanding. You need to have some common understanding between your roommates or among your roommates if you have multiple roommates, like 3-4 roommates. You should have an understanding. And if you follow that understanding with each other, then we will say my roommate is a cooperative one. He cooperates with everybody. But if someone of you may not follow that understanding, then we will say this particular person is not cooperating. He is not a cooperative guy. He doesn't cooperate with anybody. In the same fashion, we can say that you may have multiple processes concurrently executing in the system, like 5, 6, 7 program, but all 5, 6, 7 program may not independent because there are a lot of resources which are common for each other. For example, you have only a single accumulator. You have only one PC value or program counter. You may have some common data structure. You may have some common file. You may have some common database. So you need to provide some kind of common understanding such that all the concurrently executing process will follow that understanding. And if it is that, then we will say the processes are cooperating with each other. Otherwise, we will say that the processes are not cooperating with each other. And if the process doesn't cooperate with each other, then that will lead to some erroneous result. So let me come to an example, very interesting example I will give you. Then this idea will be clear. দেখো তো দেখা হোয়াইট বোর্ড যাচ্ছে
Yes, sir.
Yes, sir.
আমার পিচ খুলে গেল বলছে কই গো
So you open MS Store, sir.
এমএস তা আমি কি এখানে ক্লিক করলাম তো ওটা খুলে গেল তো
Whiteboard 99.
হোয়াইট বোর্ডটাকে আলাদা ইনস্টল করে দেখাচ্ছে তো আচ্ছা কত কাণ্ড পরে রে বাবা দেখতে পাচ্ছ হ্যালো
Yes, sir. Yes, sir. Yes.
ধরো there is a common variable a or global variable which is initialized with 1000 There are two concurrent processes. There are two concurrent processes. Both are accessing the same common variable. The code of this process is mind it, A is a global variable, that means which is accessible by all the concurrently running process. There are two processes, P0 and P1, which are concurrent in nature. That means both the processes exist in the system at the same time. The code for P0 is this. The code for P1 is this. What is the final answer of A? Well, what do you think the first is the final answer?
Sir, A plus 100, sir.
হ্যাঁ
A plus 100, sir.
এই তোমার কথাই শোনা যাচ্ছে না, তারা
A plus 100, sir. আমার মাইকটা বন্ধ করা হচ্ছে actually.
খেতে খেতে দেয়নি নেই তোমার মা আজকে বলো না
হ্যাঁ,
খেয়েছো সকালে খাবার দাবার?
হ্যাঁ স্যার খেয়েছি।
শ্রাবণ মাসের উপবাস করছো তুমি আবার, বলো কি হবে?
স্যার A plus 100.
বুঝতে পারছি না তোমার কথা।
A plus 100, sir.
I want the final answer.
ও আচ্ছা
1100.
1100.
1100. Anyone else? Anything else?
Yes, sir. It could be 900 also, sir.
Who told this?
Sort of.
Saurabh. Saurabh told it could be 900 also. Tojo to আর কে বললে 1100. Anything else?
And 1200 too, sir.
Good, very good.
1200 too.
हैं? और कुछ?
No, sir.
और कुछ? Saurabh, tell me the reason for 900. Saurabh,
Yes, sir.
yeah, tell me the reason for 900.
Sir, if it do contact switch, sir, then the answer can be 900. Like first, it will go to process P1
Hmm.
and it will do 1000 minus 100. That is, it will be 900.
Hmm.
It will store a 900, and after that statement, it will be contact switch to process P1, and it will again add the value of 1200, and when it will be back to process P1, then it will write 900 in A.
इसमें 900 आएगा, 1100
So
आएगा।
your
हाँ? What is the reason behind 900? Who can give the
okay. Sorry, sir. When
Yes.
it will be from process P1, sir, it will be A will be 1200, and after that 1200 it will be do contact switch to process P1, and 1200 minus 100 it will be 1100.
Okay, so 1100. तुमने तो बोला 900. हर्षित क्या बोल रहे हो?
Sir, both the processes will read A value as 1000, and sir, P0 will modify A to A plus 200, and meanwhile it switch to P1 process. So it will give A is equal to A minus 100. Or
Okay.
sir, we can say like P0 initially added 200 and write it 1200, but P1 has already read A as 1000. Now it will subtract 100 and save it as 900. So answer will be 900.
Good, very good, very good. What about the 1200? Harshit, can you give the same reason for 1200?
Yes, sir.
Tell me the reason. Or let us note down the instruction number. Instruction number 1, 2, 3, 4, 5, 6. See, I am again telling you, process P0 and P1 are concurrent in nature. That means their instructions or that execution of the instruction can be in any order. Maybe some instruction of P0, then some instruction of P1, or some instruction of P1, then some instruction of P0. So they can be executed in any order, or P0 completely, then P1, or P1 completely, then P0. So their execution can be in any order. Okay. अभी बोलो हर्षित बोलो.
Sir, instruction number 4, then 5.
Instruction number 4 हो गया इसको 1000 नहीं. Instruction number 4 it reads 1000.
Instruction number 5.
It inside the variable it becomes 900.
Then instruction number 1.
Then instruction number 1 it will read 1000.
Then instruction number 6.
Instruction number 6 इसको write कर दिया, it becomes 900.
Then instruction number 2 and 3.
हो गया 1200. Write कर दिया 1200. So it becomes. Hold on. Do you understand this thing?
Sir, but A is a global variable, so when we are decrementing A by 100, won't it be changed to 900? Sir? Why would be P0 is
for any instruction you need to think in a micro level. Okay, so when you write, so I assume that you have already gone through computer organizations. So when you write add A plus B or A plus B is basically it means load A, add B, then store the result. So basically load A, that means it will be loaded in the accumulator. Add B, then accumulator value will be changes, accumulator equal to accumulator plus B. Stores AC, that means accumulator value will be stored. So if you see, the micro level instruction is very narrow down. I mean, so while A equal to A plus 200 happens, it doesn't mean it has been written in the memory. It has been modified in the memory. It doesn't mean. Now, when you are executing A equal to A minus 100, that is 900, but it has not been written here. It has been changed in the accumulator. It has been changed in the accumulator, but not it is changed in the memory. So to change in the memory, you have to write it, or in a assembly language, you have to execute store. Or store কি ছিল জানি না, store এরকম কিছু একটা. বুঝতে পারলে সব কিছু?
Yes, sir. Yes.
So if you allow these two process, to be executed in any order, and we assume they are concurrent in nature, then their instruction can be executed in any order, and that may lead to the result of 800, it may lead to 1100, it may lead to 1200. So for the computer execution is concerned, all the results are correct result. But so far our expectation is concerned, it should be 1100. We expect the result should be 1100. But so far the execution of the instruction of a computer system is concerned, it may take to 900, 1100 or 1200. So you need to make some kind of mechanism, some kind of understanding such that process P0 and P1 will cooperate with each other. कैसे cooperate करेगा? When we will be accessing a global common resource, either you access completely, then I will be accessing, or I will be accessing, then you will be accessing. No two persons will try to access at the same time. Again, come to the hostel. You are 3 people staying in a single room. You 3 people in your batch staying in the same room. There is only one RJ45 cable which can provide you internet connectivity. You don't have any Wi-Fi, no hotspot. So to access internet, you have only one RJ45 cable through which you can access internet. But there are 3 people. So at a time, more than one person cannot access internet because you have only one RJ45 cable. So you can make a mechanism or understanding with the idea if someone will do in the early morning, who wake up in the early morning will be using the internet in the early morning. Another person tells, okay, in the evening mein hum kar lenge, college se वापस आने के बाद I will use the internet. Another person tell, okay, I have a habit of late night, मतलब रात जागने का. So I will use the internet after dinner. So in this way, you have come up with a common understanding that all the 3 people will be accessing internet through RJ45 cable with some understanding. किसी ने सुबह करेगा, किसी के शाम को करेगा, and someone will be doing the night. So in this way, these 3 people have come up with an understanding to cooperate with each other to access a shared common resource. To access a common resource. And the same thing happens here. If you don't allow any understanding between P0 and P1, it will lead to an erroneous result. So you need to bring some kind of common understanding between P0 and P1 through operating system code, through operating system algorithm, such that P0 and P1 will cooperate with each other because they are cooperating process. They are concurrent process. So you must have to cooperate them. বলো বুঝতে পারলে কিনা কথাটা? How this can be done, we will be discussing later in the next chapters. Just today we are discussing all the issues of what are the issues that can come while we will deal with process. কি হলো কিছু বলো?
Yes, sir. Understood.
हर्षित समझ में आया?
Yes, sir.
अनुपम?
Yes, sir.
सौरभ? कुलदीप?
Yes, sir.
देखो if you yeah, Kitish?
Yes, sir. Yes, sir. Sir,
Is
can
the idea clear?
object-oriented concepts for solving this problem can be used? Means we give the local variables access to a particular class so that other class functions cannot access.
No. There is a solution for this type of problem. Is called process synchronization. This is a separate chapter which deals with this type of situation, that is called process synchronization.
Okay, sir.
You have in detail of this chapter. That is process synchronization. Why synchronization? The process have to synchronize to access common resource. Now, here I need to use two more terms. Shared resource and common resource. বলতে পারো কোনটা কি? What is shared resource? What is common resource?
Sir, shared resource in in that case there is like a specific amount of time that the process can access the resource, and in case of common resource it's always accessible by the participating processes.
কোনটা কি বলো? 3 people staying in a hostel room. There is only one ceiling fan.
Sir, a fan is a common resource, sir. The RJ45 is a shared resource, sir, because
উল্টো বলে দিলে। Fan is a shared resource. Fan is a shared resource. Fan is a shared resource. This is a common resource. Why?
So because common resources can be used by a single person at a time.
Common resource can be used by a single person at a time. Number of instances, jitna number of instances, that many number of process can use it. If you have 2 RJ45 cable in the room, then out of these 3 people, maximum 2 people can use it. But if it is a shared resource, all the 3 people can use the ceiling fan at the same time. There is a TV in the hostel common room. It is a shared resource or common resource?
it's a shared resource.
Shared resource. Because 20, 30, 50 people sitting in a common room can watch the cricket match at the same time from this TV. There can be 40, 50, 60 people staying in the same common room can watch the cricket match from the TV. So it is a shared resource. That RJ45 cable is a common resource. দেখো তো গেছে কিনা এটা? Is it visible?
Yes, sir.
Yes, sir.
Yeah. In perspective of cooperative process, there is a one classical problem of computer science that is called producer-consumer problem. What is this? There are two processes. One is producer process. Another is consumer process. There is a buffer. Do you know what is buffer?
Storage.
Temporary storage.
Storage.
Temporary storage is called buffer. There is a finite length of the buffer. Let us assume the length is 5. Producer produces the item and it puts in the buffer. Consumer takes an item from the buffer and consumes it. One is producing, another is consuming. One is producing, another is consuming. Producer produces item, put it in the buffer. Consumer consumes the item from the buffer. Now this buffer is a finite. Finite means it is not infinite, it is a finite value. Maybe it can hold 5 items, it can hold 10 items. I mean, infinite, it is not infinitely large. It has a boundary. That's why it is called bounded buffer. So this problem is also called bounded buffer problem. Okay, so there are, again I am repeating, there are two processes, producer process and consumer process. Producer process produces item, put it in the buffer. Consumer process takes the item from the buffer and consume it. Now, producer and consumer are two independent processes. Independent process means they don't have any communication or any dependency. They are producing and consuming independently without depending on anyone else or without depending on one another. Now, if I assume the speed of production of producer process is higher than speed of consumption of the consumer process, what can be the possible problem that you may face here?
So there can be overflow of items in the buffer.
Stack overflow.
Okay, or kuch? Or anyone wants to say anything?
So underflow.
বাকি লোকজন কি তোমাদের নেই নাকি বলো তো? বাকি লোকজন এই কয়েকদিনই শুধু বলে। রোহন গুপ্তা, রবি গুপ্তা। Prasanna, are you there here, na? Prasanna?
Hello.
हाँ प्रसन्न.
Yes sir, am I audible?
अरे तुम इस क्लास में हो?
Yes sir.
तुमको तो कभी देखा ही नहीं कि you are attending this class.
अरे sir.
बोलो, what is the issue or what can be the possible issue in this system?
Sir, actually, at this moment I'm little outside, so I'm not able to attend everything. I'm little outside, so for some important work. So I'm on my mobile.
Very good. Pranit Pandey?
Yes, sir.
Tell me, what can be the possible problem?
Yes, the buffer can overflow because more data is coming in, less data is going out.
So, again, there are two processes. Yes. Producer process. Follow, Saurabh.
Sir, Yes, sir. It can be like before production, consumer start to consume, and then there will nothing in the stacks.
Yes, of course, of course, of course. So if I assume that the producer execution of the producer process is higher, execution speed of the producer process is higher than the consumer process, the rate at which it consumed. So it may produce the item which may not be kept in this finite size buffer. So there will be an overflow. There will be an overflow of item. There may be an overflow of item which will be lost. The other issue can be if the rate of consumer is higher than the rate of production process. So in that case, it may so happen that consumer consumes so fast that after sometimes it becomes underflow. That means there is no more process, there is no more item, and consumer is going to consume the item. That is called underflow. So both underflow and overflow can take place. This is called producer-consumer problem or bounded buffer problem, because as
Sir,
bolo.
স্যার আন্ডারফ্লোটা তো স্যার আনবাউন্ডেড বাফারেও তো হবে, যদি কনজিউমারের স্পিড বেশি হয় তাহলে প্রোডাকশন করতেই পারবে না তার আগে।
একদম রাইট ভেরি গুড আব্দুল, very good idea. So there is no restriction about the bounded or unbounded in the case of underflow, right? So if the consumption rate is very, very high than of the production rates, then whatever the buffer size is, in some point of time, the consumer will find there is no more item in the buffer to consume. So that will lead to the term underflow. So this problem is called the producer-consumer problem. So what can be the solution? The solution could be you can make some kind of cooperation with some understanding between these two. Before production, producer process will check whether there is any free space in the buffer or not. If there is a free space in the buffer, then only the producer process will produce and will put it in the buffer. Before production, the producer process will check the buffer whether there is any free space or not. If there is any free space in the buffer, then only the producer process will execute and the product it produced will be kept in the free space. If it finds that there is no free space in the buffer, then it will stop producing. It will only produce when it finds there is free space in the buffer. In the same way, before consumption, consumer process will check whether there is any item in the buffer or not. If there is any item in the buffer, then only it will consume, otherwise it will not consume. That means otherwise the consumer process will not be executed. Bolo, is the idea clear?
Yes.
Can you write the pseudocode for it? You can consider it as a queue, or it is a circular queue. No, circular queue. You can implement it as a circular queue.
So why a circular queue? Why not a normal queue?
ঠিক আছে, এখন তুমি তোমার মতো করে করো না. No problem.
No sir, I was asking why circular.
No, I won't say. You are computer science. You people are computer science people. I should not say. হ্যাঁ বলো আব্দুল।
স্যার এটাতে স্ট্যাকেও ইমপ্লিমেন্ট হবে।
What?
স্ট্যাক ইউজ করে মানে স্ট্যাক ডাটা স্ট্রাকচার।
তোমার তো লাস্ট ইন লাস্ট আউট হয়ে গেল, লাস্ট ইন ফার্স্ট আউট হয়ে গেল।
ও
Nitish, what about you?
Yes, sir. Circular queue, I think it will be good because circular queue saves optimization. Because first, if there is empty, so we can go back to the 0th position. But in case of normal queue, then it will show overflow only. So circular queue is more optimized. So I think that will be a better data structure.
Normal queue can also be implemented using linked list.
Okay, so what you need to do, I think the problem is clear. The solution is clear also. I have not discussed the actual code intentionally. I will expect you people should write the pseudocode of it, and at least for the time being you write the pseudocode, and of course if you can do the simulation of it, it will be good in any programming language. Will you try it? Malo. কি হলো? Yes or no বুঝতে বলো?
Yes sir.
You should try. You should try it. Unless you write the pseudocode and the code of the this idea, I mean the feelings will not come as an operating system subject. ठीक है? तुम लोगों को feelings आना चाहिए. You are studying a subject as a core computer science subject. You should have that feelings. ঠিক আছে? চলো then for today. But this intentionally I am not going. So you will check with the while loop. Okay then, bye for today.
Thank you, sir.
Hey, Abhishek. হ্যাঁ অভিষেক, আমি এই ফ্রাইডে একটু 9টা থেকে ক্লাসটা নেব। ঠিক আছে, ফর দিস ফ্রাইডে।
হ্যাঁ স্যার।
Okay, bye. Thank you.
Thank you, sir.
Thank you sir.
Thank you sir.
Thank you.